Hello everyone. My name is Ali Reza Darbahani, and I'll be the moderator of the talk today. And the talk, as you know, like it's about Edge AI, the next frontier. I'm so glad to host Don Ward. Don is a senior software engineer on the data science team at Quicken Loans, the nation's largest mortgage lender, which is based in Detroit, Michigan. As the previous director of mobile development at Quicken's Loan, he has been building mobile apps for the past 10 years. He leads the local chapter of the Google Developers Group in Detroit and Windsor, Canada. And he's always up for a good challenge. He entered and won a 24 hours hackathon, leveraging the power of wearable technologies such as Apple Watch. So please feel free to post any questions you might have in the chat, and we will try to answer those questions. If there are like clarification question, we'll try to answer at the middle of the talk. Otherwise, we'll leave it to the Q&A part of our talk today. And without further ado, Don, the floor is yours, and please take us away.
Yeah, definitely. Thank you. Appreciate that. My name is Don Ward. Let me get my screen share going here, and so that you can all see what. Appreciate the great intro there. And as I said, my name's Don Ward. I work at Quicken Loans in Detroit, Michigan. Quicken Loans is the largest mortgage lender in the United States. Growing company. Currently 90% of our team is in Detroit. I work in downtown Detroit. I live in Windsor, great company to work for. And I've been around Quicken for 8 years now, many various roles. But my current role, I'm on the data science team. And today I'm going to share some really cool stuff that I'm excited about. I've been working with this for various capacities for the last 2 years, EdgeAI, and applications at Quicken and just on the side. So I'd love to share. And if you have any questions, if clarification questions, don't hesitate to stop me, or we can wait till the end and I can answer those. So let's get started. Let's talk about you. So it's always good to know your audience, and when you do a presentation like this, and I'm trying to get an idea, but I imagine that most of you train models out there. You train models, you run models, AI, run them, machine learning models, and where do you run them? Where do you train your models? Where do you run them on a day-to-day basis? If you're like most enterprises or most practitioners of ML or AI, you run them in servers in the cloud. So you do your data's there to begin with. Usually you have a data lake or a data warehouse that you're pulling in data, much like we do at Quicken. You're pulling in that data. You're running, you're training models on it on very powerful computers in the cloud. Have tons of GPU power, and you're also running those. You're training, and then you're doing usually a lot of the outcomes of those training. The models that you run end up as either microservices or some part of a pipeline of a machine learning running on servers in the cloud. So let me ask this: what if we could train and infer on data closer, or train closer to the data? So say the data lives out in the real world, but it's not something that's stored on a server. What happens if we could have inference happen in real time with no network latency? So from where the data is collected on a sensor, for instance, you can infer on it. You can collect over milliseconds, hundreds of samples, and infer on it with no network latency. This is what EdgeAI makes possible. So this is the whole concept, is moving AI and moving those, for the most part, I'd say 90% of the workloads are inferring on the edge, which means closer to customers, closer to the actual input signals that you're trying to make inference, decisions off of. So this is what EdgeAI makes possible. So let's talk about where would you see EdgeAI being used? Where right now? So first thing would be smart home assistant. So your Google Home, Alexa, they're running this right now. I mean, and these things are growing in numbers, right? Everyone's got one. I think last count I have 8 in my house right now, Google Homes, and we use them quite a bit. And yeah, obviously they do AI. They're very, when you talk to them, they're doing natural language processing. They're figuring out what you're talking about. They're doing a lot of that workload in the cloud. But in terms of edge AI, what are they? What part is that would be edge AI? Would smart home assistants be doing? Well, that would be the trigger word detection, so that when you say Alexa, there's a small microprocessor or a DSP for that case on the device that's constantly running inference, looking for a trigger word detection. So it's looking for the word Alexa. When it hears that and infers it on device, then it can give you that split second response. How can I help, or whatever the next phrase is. So that's one place where Edge AI has been kind of actually like one of the places where it started to move, or started to kind of get its roots, was smart home assistants. And if you think about it, you don't want that edge detection to actually the device to sample your audio, then send it up to the cloud, have some server make a decision on it, and come back and say, yeah, you should wake up and be triggered now. The latency would be too long. So this is one area where you see edge AI these days. Another one that makes total sense is mobile phones. I mean, everyone's got one in their hands. I can't live without mine. I think I spend 3 to 4 hours a day on it, and we'll get into a little further about what you can do with that. And I'll show you some simple ways that you can get started if you've got custom models that you've trained, or just models that are off the shelf that you want to run on mobile devices, how you can get started with that. The other area, this is really exciting to me, is microcontrollers and microprocessors. So those who aren't totally into this, microcontrollers are more of the low-end devices where everything is on one chip usually. The processor, the memory, all on one chip, and they're very small. They can run pennies in production to build and to code and use, and they're designed to run a long time. Microprocessors, on the other hand, are a step up, a little more powerful processor. Not everything on one board, or on chip. Not everything on one chip. Excuse me. More like everything on one board, but they're more powerful. So these are areas where edge AI is being used. So why would you, to recap what I just talked about there, why would you want to do edge AI? What's some of those reasons? So one would be that no network latency. So if you have a device that has sensors, you've got no network latency of having to do the inference up and sending it across the data across the network, getting a response back, and having that come to your device. Real-time decision making. So obviously, no network latency, sensor feeds right into your model, and you get decisions right away. Another thing would be, these are things that more affect your user, but also, how about the idea of, I have a device that's like a microcontroller that's meant to run by itself, and it's meant to run, but it has limited battery, because it's being powered usually by a battery, or it has limited resources in terms of RAM. What would be really cool, you could use Edge AI to determine, when should I conserve energy? When should I turn off certain resources? When should I maybe, okay, this device shouldn't be turned on right now, or it should go into a sleep state because the inputs say I don't need to do the processing right now. So using that type of conservation, so that you can either save the battery life on these devices, or processing power is one way, or even memory for that another case. So what's the size of the industry? Why now? Why do I call it next frontier? Well, it really comes down to, in terms of smart assistants, which we talked about those first. I think EdgeAI is pretty much here. There's not much, that's going to be done more on that end. But mobile phones, there's lots of apps out right now that have some sort of ML in them. They're using, pre-trained models, and it's easy for you to take advantage of that and use it if you have a great idea, or if you want to create your own custom model. The other area that is, and everyone has a smartphone, obviously. The other area, microcontrollers, microprocessors, and this is what really kind of blew my mind when I started looking at it, is to date, right now, there are 250 billion microcontrollers out there running in the world. To give you an idea how fast this is growing, in the year 2018, that's the last year I could find data on, they sold 28.1 billion microcontrollers. So they're all embedded, your washer, your dryer, all your home automation devices have them. Your car has probably 20 or 30 in there. They're all over. And they're predicting that the continued growth by 2023, there will be 38 billion of them sold in the world. Now, there's a lot of use cases out there of why would you, how can you improve those microcontrollers, those microprocessors, and how can you make them run better, even with robots? That's another area for microprocessors, especially to make a big impact. So in terms of EdgeAI, I feel it is early days, really down towards the lower end devices. Just started seeing, like in the last year and a half, more movement doing AI on those devices, and that's really exciting. So let's talk about the use case of mobile. As I mentioned, a smart assistant, I don't have a lot more to share on that, but mobile, I used to work at I worked at Quicken Loans, but I used to work in mobile. I was a mobile developer, their first Android developer they hired, and always have been involved with still doing mobile development on the side. And it's interesting because as ML became easier to use, we started working with, we started using models in our apps. And one way you can leverage this, which we don't do at Quicken, obviously, but would be face detection or image detection, natural language processing. You see that on the Google Pixel 4 these days. They're doing that right on device. So these are places where they're doing on-device AI. So how could you get started? One easy way I would say is if you've ever used TensorFlow, which I imagine a lot of you have, what I found is TensorFlow has, as a ecosystem, probably moved the furthest towards the edge in terms of support. So they've developed the libraries, the converters, all of that to get their models to run on edge devices. So TensorFlow Lite is a subset of TensorFlow. It doesn't support all the operations that TensorFlow Core has, but TensorFlow Lite definitely is what you would use to run on mobile. I'm not going to take you to that website, but here's a simple app that I taught this at a conference earlier this year. I taught on how to develop this app for your Android or your iPhone. This is a app that's done in a cross-development platform environment, and basically a very simple app. You grab an image and from your gallery, and it does face detection with an out-of-the-box, machine learning model, and draws a mustache on there just for the heck of it. If you go to that GitHub repo here, I step through step by step how to actually develop this app and get it running on your phone, so you could deploy it on your iPhone, your Android. You can take it from there. You don't have to just do face detection. So let me show you a little more here. Oh, sorry. So this is what I'm leveraging. The technology I'm leveraging there is from Google. It works hand in hand with TensorFlow. It's called Firebase, and Firebase is a set of services that Google has released over the years for mobile developers. They also have some JavaScript hooks in there, but it allows you to put together mobile apps with a back end and take care of a lot of those services. For instance, push notifications, things like A/B testing, all these types of services that you might want to use in a mobile app. Firebase makes it easy for you. But the cool thing about it is 2 years ago at Google I/O in 2018, they announced this thing called ML-Kit. And ML-Kit is a machine learning kit for Firebase. So it makes it very easy for you to actually grab pre-trained models if you need them, or even using your own. And look at, this is a snapshot from their website, but these are all the models that they're giving you that will run on device. They don't have to make any calls back over the network to Google servers. Once your app's installed, these run on device. You can put the app in airplane mode and run these models. So you've got text recognition, face detection, barcode scanning, goes on and on. Here's a cool thing, a custom mono inference. So recently at Quicken, can't share too many details, but we took a custom model that we developed for a server, ran it through TensorFlow Lite as a converter, and was able to get that running in an Android and iOS app. And we have plans for it going forward. So it's custom model inference. Now the one caveat is obviously not all the operations that are supported in TensorFlow Core are supported in TensorFlow Lite. It's interesting that they've got a few models that run in the cloud still. So text recognition, image labeling, and landmark recognition. And what's the difference, I guess, between on-device and cloud in these cases? Really, that boils down to the on-device recognition, like text recognition, for instance. That offering, it doesn't have as many features as you could get from the cloud. So they're using some of the more, they'll give you more information if you give like put a document into Google Cloud and load it up through Firebase. They can do better text recognition than you would get on device. But the gap is starting to narrow. I mean, this list has grown over the last year, and it will continue. This one here is also pretty exciting. If you've got an idea for a mobile app, or you've got one out there, Smart Reply. I don't know if everyone knows what Smart Reply is. The ability in Gmail right now on mobile where you're typing and all of a sudden it tells you what the rest of the sentence should be. They made that model available to be used anywhere in your mobile app. So any text input you have, you can use it and run it on device. The other one that's really cool is translation. The ability to run what Google Translate, the Translate app, run that on device. Interesting thing is if you're translating from, say, French to Spanish, the way they did it, they packaged that was the Translate app that you would bring in the translation from French to English, and then you would bring in the translation from English to Spanish. So to make the model smaller, they actually did every language back to English and then English to every other language. That's how they packaged that up. So pretty cool stuff. This is a great way to get started on mobile, rolling out your own models. I know iOS also has some of their own custom, frameworks to run models. Firebase plays with them, and they also have ways to train models. But this is really a good way to get started if you want to take one of your models or an idea that you have for a pre-trained model and get it onto a mobile device. So here's another area, and this is something that I've been passionate about for the last 2-3 months. I've been doing a lot of work, microcontrollers and microprocessors. I've actually I'm taking a little bit of a break this week. I just started taking this break, but for the last 3-4 months, I've been doing this 100 days of code challenge. So every day you commit to 1 hour of code outside of your normal work day. And I've been doing my 1 hour of code playing around with microcontrollers specifically. So let's get into what that looks like. So how do they leverage ML? you know, there's a lot of ideas around this, and there's no killer app yet, but microprocessors here. That image you see on the side there is from an NVIDIA board. That's a microprocessor doing, person detection, obviously. And you can do natural language processing. The cool thing with microcontrollers, they're small enough that they can be embedded in things. So your smart watches, your wearables can definitely leverage them, or some, primitive models. So this is pretty exciting. Here's just a really brief, if you wanted to get started, this is not a comprehensive, by any means, comprehensive slide of what some of the players out there in that space. But if you wanted to get started, you wanted to say, do this talk, you said, I want to go play with some of this stuff. Here's where some of the devices as I've seen them evolve over the years. So when we start up in the top left here, NVIDIA's got it. Jetson is a whole line of devices that are really optimized for machine learning. The Nano developer kit starts at $99. This thing is a beast. It's basically a Raspberry Pi with a huge GPU strapped to it. They've shown demos where it can process up to 8 video streams at once, 30 frames per second, and it's just a really nice package, $99, and it's a Ubuntu computer. I have one at my house, and you can basically hook keyboard, mouse up to it, or you can just SSH into it and run your models. It runs TensorFlow. It also runs TensorFlow RT, or TensorRT, which is NVIDIA's version or way that they convert TensorFlow models to run in real time. So it's really slick. If you want to check that one out. This not to be undone or outdone. So NVIDIA released this last year. Google shortly after released what they call the Google Edge TPU, which the TPU, these are the TensorFlow processing units. For the last 5 years, Google has been developing these TensorFlow processing units to run in their own data centers to do machine learning and to run machine learning loads and AI, and the bigger, and actually if you're in Google Cloud, you can actually specify, I want to use a TPU. So they brought these TPUs to the edge. And you can buy this board. I just checked it today. It's $130. It was a little more when it came out. Very powerful. You get a little more documentation and a few more examples with the Edge TPU than you do with the Jetson Nano, but the Jetson Nano seems to have a fairly large community. They actually have a self-driving car challenge that you can take on too, and they give you the blueprints to do that. Interesting to note, check out the heat sinks on these, the fans. Like, these things are when they do inference, they get very warm, and they're not drawing too much power. I mean, 10 watts, 15 watts. I just read about NVIDIA's Jetson Nano has a bigger brother that comes in at $400. It just got released in May, and this thing is a beast in terms of it runs Docker containers. The video they show it has 4 Docker containers running on once on it, each one of them running a machine learning model, one for image recognition, or sorry, person recognition, another one's running PostNet, another one's running natural language processing. All 4 of these Docker containers, separately developed, all running on one of these boards. Not much larger than this, and it runs at 15 watts. It's amazing, and this is geared towards running on robots and things of that sort. So decreasing in computing power, we get the Raspberry Pi 4. You see, I've read it. I haven't played around with it a lot, to tell you the truth, with running machine learning loads on it, but it's definitely out there. $35-$40 you can get one of these, and you can do that. But it doesn't always have it doesn't have the processing, the GPU power that these things have. And then you get into the really interesting area. So this here, SparkFun Edge, was kind of an interesting board that came out last year. They announced it at Google I/O, or actually, no, sorry, the TensorFlow Summit. It was also announced at Google I/O. So that would have been April timeframe of 2019. This thing runs TensorFlow for micros on a board. It's an ARM chip. And on the other side of that board, there's actually a spot for a coin battery, and this is embedded. Now the example that they came out with and they showed everyone, they said, this is so cool, is it was a trigger word detection, yes or no. So it would detect the word yes or detect the word no. And the model that they had gotten, they brought the model down in size to 20K. So they were running a model on here, the mic was listening, and it would detect yes or no and light up different LEDs on here based on what came in from the mic, but all running in 20K. This is more exciting. This board here, the Arduino. Now, if anyone's ever heard of Arduino, these are kind of like the hobbyist microcontrollers out there. This one came out in November of 2019. I know that the guys from Google partnered up with the Arduino team to bring this out. And this thing is a little bit of like a really cool board because it has so many sensors on it. To give you an idea, it has accelerometer, gyroscope, temperature, humidity, color sensor, proximity sensor. It has a mic. It has all that packed on this little board that isn't much larger than a Fitbit. It also has obviously that processor, and it runs TensorFlow Lite for micro. You can plug it straight into your computer via the USB, and thing will run off of a coin battery, not for very long, but you get the idea, because it's a lot of these sensors that it's included draw a decent amount of power. But it's cool that you can not only sample the other thing is it's Bluetooth. So this is something I've been playing with lately, is sampling training data, for instance, motion data, like, I made a motion, sampling the sensors to see what the motion was. Say I moved my arm from left to right, or I made a circle or something of that sort, sampling that on the board, and then streaming it over Bluetooth to my computer so that I can actually train the model, use that as training data in a Go Code Lab, and then take the model once I've trained it, convert it down to run into TensorFlow Lite for micro, and run it on this board. So pretty cool stuff there. If you're interested in the the microcontroller stuff, there is a great book out there, TinyML. I'm halfway through it right now. This is kind of your definitive book to get you started. It starts from scratch and explains microcontrollers, explains machine learning, which maybe this audience doesn't need to know about, but explains all of the ins and outs, and it's really good in that respect. So it's early days in this type of stuff, the TinyML, but I think there's a lot of cool things and once you know the process of like taking a model that was trained in TensorFlow Core, running it through the TensorFlow Lite converter, and then what you actually essentially have to do is flatten that model out so that it's a very small model with quantized weights inside of it, and you bring it into your machine learning, into your microcontroller. Basically, you bring it in as a header file with a number of unsigned integers in it, and you can run inference on it. So it's very cool. So that's what I've got. I go build. I can show. I don't know where we're at for time right now. Looks like I'm at 7. Oh, my clock says 7:17. So we are close to the end here, but let me stop sharing. I can take questions. And if you want, I can even show you some of the code or anything of that sort, because this is something I'm passionate on, and I've been doing it for last 45 days or so. So what do we got here?
Okay. We have a couple of questions. Some of them are mine. The first question: how is the best performance of the edge models using the TensorFlow Lite? Like, do you see any lag, or
So I guess it really depends on your hardware. The thing about TensorFlow Lite, like there's a converter as part of the TensorFlow toolkit that you run on a model. What we've run against is, and we've had to do this a few times, is we maybe have a custom model that was trained for server and TensorFlow Core, and we go to convert it to light, and all of a sudden it spits out and says these operations are not supported. So our data scientists had to go back and retrain it or make modifications if needed. But in terms of the performance, you're not, it really depends on what device you're running on. Some of the NVIDIA ones, like I would encourage you to watch some of the Jetson Nano videos if you really want to get an idea. They're running in real time, and these devices are, so especially the micros, if you've ever worked with a microcontroller, they're optimized so that they don't have, they're consistently running the same, at the same tempo, for instance, same frequency. So you can't do things like allocate memory on the fly on a microcontroller. Because of that, these things run predictably. So for vision and ML models, yeah, I think your best bet is with the microprocessors, the Jetson Nanos, the Google Edge TPUs. That's where you're going to get with the vision and the NLP models. Although I will say the Arduino has a vision, very simple vision model running on it that you can actually download and run. So that's pretty cool. So you just have to consider that these things have limited resources.
Right. Sounds good. The next question, if I understand it correctly, is like, which microcontroller would you suggest from the feasibility standpoint, like code-wise? I guess you already answered the question in a sense.
Yeah, I can actually elaborate a little more on that one. So microcontroller puts you into the Arduino, Adafruit, Spark. Those are some of the big players in that space. I've tried out a few of them. I find the Arduino ecosystem fairly simple to get started. I wouldn't use their IDE. There is a great extension for Visual Studio Code. It's called Platform IO. It supports a ton of different microcontrollers. I've been writing C code using Platform IO and VS Code for that Arduino that I showed you, and been working with it. And it's easy to use, super simple to get started. And they have the serial monitors and a serial stream coming in. So the Bluetooth's been a little difficult, I'll say that much.
Cool. So
remote deployment.
Okay. Yeah, that's my question.
Good question. So, I mean, the microprocessors have Wi-Fi, and they have, so you can deploy from, you can SSH into them, you can do stuff like that. The thing about microcontrollers is they're not all, like, a lot of times they're meant to be flashed and used. So they're not always set up for that. A lot of times they don't have the resources in certain cases to actually hold too much of an extra program in memory and flash out the old one. But, and there's platformio.org. Someone knows about it. It's really good. So.
Cool. Yeah. And I guess somebody mentioned they would love to see some more code. If you have something handy.
Sure. Yeah, sure. So I'll show you just to get a little bit of like what you can expect in if you've got VS Code. Let me show you here. Okay, so here's an Platform IO project in VS Code. This runs on Arduino, and what it is it's gesture recognition. It's pretty simple. I've been basically, it's one of their examples that they give, but I've been extending it and making it a little more robust. I've also taken it and started doing the sampling of training data based off of a button that I've hooked up. I don't know if you can see this is what I'm working with right now. So you can see I had to do a little bit of soldering and everything else on there. But this is Arduino's TensorFlow Lite library. But the thing about this is if you were to drill into the TensorFlow, pull the TensorFlow code base off Git, and you drill into the Lite directory, there's a micro directory. you will find this, pretty much this whole directory structure in there with examples for a few different project. Magic Wand, micro speech is at that trigger detection and person detection. I don't know, I haven't tried that one out, but you have to have a camera hooked up to your device. And it's got all of the source code for how you would actually, like the core, the light libraries and everything. Now, the gentleman that wrote that TinyML book, Pete Warden, is one of the guys that is actually quite involved with maintaining this part of the TensorFlow library overall. What I've done here is, in this example, I brought in the whole TensorFlow Lite library to Arduino. I also brought in this library here that hooks me up and gets me readings from the IMU on the board, which is gives me accelerometer and gyro. Obviously, this is a C program, so you write it in C++. Here's an interesting thing. So these are my samples. I've trained, I grabbed some data, but here's the model. Oh, sorry. No, this is a model. So this is what the model ends up once you've run it through a converter and flattened it into, instead of, I'm forgetting what TensorFlow Core stores their models in. I don't think they're a type of buffer, but it's part of the gRPC standard. But in terms of the micro, they use a flat buffer, which quantized it, and also it takes out some of it makes it much smaller so that your model ends up looking something like this. And when you use it in your code, you actually you load up an interpreter, which I can show you a little bit down here, and you bring in the model as in your code. You instantiate an interpreter here. Interesting thing is, when you bring in the model, you have to allocate your memory for the model, and that is kind of a black magic where it's guess. It's basically bring in your model, and if allocate as much memory as you have left for the first try to see how it works. If your controller crashes, then the model's too large for your controller. And if it runs, then continually decrease the amount of memory allocated for your controller. And that's right. Continually decrease the amount of memory for your controller until the model stops running. And I'm trying to find that code here. Maybe it's up here. So that's really just, it gives you a brief overview, but here it is, tensor arena size. So this is a little larger model. It's 8 times 1024 bytes. But this multiplier here is something that you have to actually play around with and find how it works. So there's no real, there's no good way to do it except for trial and error. So yeah, and then if you've worked with Arduino, there's 2 methods that that you always have to have: a setup method, which sets up everything, which is here, and a continual loop, which is, this is still the setup, sorry, this continual loop. So in the setup section, you do most of set up your input tensors, your output tensors, your interpreter, load the model, and then when you do your loop, basically here what we're doing is we're waiting over and over. We're reading from the sensor, the accelerometer, the gyro, and once we have values from it, then we actually input those. In this case, the gesture recognizer, it requires 120 samples to come up with do an inference. So you read those into your input tensor, and then eventually you actually invoke the interpreter and get your output back, which is your inference value. So that's really it in a nutshell. I highly recommend that TinyML book if you get a chance to check it out. It's on, it's pretty good. But the trial and error, I see that comment, trial and error figures. Yeah, that's not true, or not unfortunate, or not. That is the case.
Cool. I guess we have one more question, which also I had a similar question. Using ONX or Onyx platform that compiles your model for different architectures, hardware architecture, like will help improve the deployment of deep learning based process on the edge devices. And are there similar initiatives from model sharing you're aware of?
This is a great question. I imagine it will improve the deployment on various devices. I haven't witnessed it firsthand. Um, it's kind of interesting. I have a friend who works at Google, and he knows a gentleman, Pete Warden, who wrote that book. And when Pete was looking at it, he said that the first thing he did was, I want to do edge trigger word detection, and I want to do it on a microprocessor, because on your cell phone, they actually have a dedicated chip to do that. So it was kind of like he shoehorned, his library into a microprocessor. But now, as things are starting to evolve more, I imagine you're going to see that happen, where you're going to see more microprocessors using this open network, open neural network exchange, which is exciting, because there is a lot of trial and error, and um, kind of willpower through it right now to get things working on a microcontroller. But it's cool. Does that make so? Is there any other questions I can answer?
Okay, yeah, let's give people a few more seconds. And
Yeah, there's some crazy applications. One I heard about, which I thought was really interesting, was a satellite manufacturer. So, sorry, not a satellite manufacturer. They manufacture cameras that go on satellites. And what they do is they take pictures at certain times in certain areas, and they're looking for certain landmarks. And if the sky's cloudy or something of that sort, they end up taking pictures, even though they can't see anything down in that area. Think spy satellites maybe, but um, so imagine that camera, wakes up and it's burning. It's using solar energy. It's using its battery. It wakes up. It takes some pictures. It recognizes I'm seeing clouds right now, and it turns itself off. It doesn't waste memory storing the images, doesn't waste network bandwidth streaming them back to to Earth. And it just, it's a conservation thing there. So there's a lot of little areas that this is like I said, no killer app that I've heard of, but there's a lot of areas where this is just going to make things a lot better.
um, so okay, I don't think there is any other question. Thank you very much for your great talk, Don. Oh, there is another question.
Edge hardware configurations for outer space. I don't know. I don't know. I wish I knew. I wish I could answer that. That's something I have to go look after this talk. But um, you know, sounds like someone's trying to build something here. So, one more here. Small businesses. I do know some businesses in Michigan that are doing drone cameras and working with drone manufacturers to do edge AI. So things, you buy a drone, and one of my friends actually has an application that they show off where they count sheep. He's from Ireland. There's a lot of sheep farmers in Ireland, and using a drone, they were able to set it up on our Android phone, and be able to demo that they were able to count the number of sheep in a field for a farmer. So I think there's a lot of cool things like that you're going to start seeing, marrying those things with consumer electronics, which makes it really exciting. So cool.
Awesome.
Well, if you have any questions, hit me up on Twitter, Don Ward PENG. I think I can I put that up one last time here, and then
Of course.
I'll say good night. Just gotta find. So there's my Twitter handle. You can also reach out to me at Quicken Loans. Happy to talk with anyone.
Awesome. Thank you very much for your great presentation and talk, and thank you for listening and great questions. If there is no question, and if you don't want to mention anything, any additional, point, have a great night.
Yep, you too. Thanks again for all your help. I appreciate it, and enjoy the rest of the conference, everyone.